Welcome back. Like I said, we are going to be dealing with the rules involved in naming organic compounds. So let me take this out. Alright, there are a whole lot of rules, but we're going to follow them one by one. One very important thing when it comes to naming of organic compounds, first, is to be able to identify your parent chain. If you know how to identify your parent chain and the substituents therein, then you know what you're dealing with. This is what I mean by that. If I have this, let's call this. Okay, this is the compound given. The first thing we have to do is to identify the parent chain. The parent chain is often the longest chain. So how do we do that? You begin to check. From here I have 1, 2, 3, 4, 5, 6, 7. That is, for me, it seems so as if it is the longest. If I take this, 1, 2, 3, 4, 5. If I take this, 1, 2, 3, 4, 5. Either this, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So either way, this way or this way, I am good. So that is the first thing you must know to identify what your parent chain. So let's look at the rules first together so that we see what we get. It says select the longest unbranched chain of carbons as the parent chain. So that's what I just did. The longest unbranched chain of carbon as my parent chain, and name it as that of the corresponding alkane. So if it is 7, I want to name it as the corresponding alkane. It becomes what? Heptane. Because all the A and E for alkane must go with the group members: methane, ethane, propane, butane. So if this is 7, I have first of all check my longest chain, call it 1, 2, 3, 4, 5, 6, 7. And I name it correspondingly as what? Heptane. Now, there are other guys here. This one now are called the substituents, which happen not to be in the parent. They are all linked to the parent chain, but they are not a party. They do not play part in the parent chain naming that make up the heptane. So they are all called what? Substituents. So this substituent, we have various kinds of substituents, which I will list them out, I think so. We have the methoxy, we have the ethoxy, we have the ethyl, propyl, butyl, and so on and so forth. We have the hydroxy OH, we have the chloro, bromo, iodo, and so on and so forth. So let's move on. That was the first thing they have given to us. Let's take an example when they talk about the longest chain. So we have 1, 2, 3, 4, 5. Apart from this, let's take another example. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. See. So they say I should identify my what? Parent chain. It's either I call it this 1, 2, 3, 4, 5 as my pentane. So this becomes my substituent. If I call it 1, 2, 3, 4, 5 as my pentane, this becomes my substituent. But the most important thing is I have identified what? The longest parent, the longest chain, which is the parent chain. 2. Assigning numbers serially to the carbons in the parent chain, starting from the end nearer to the first substituent, the side chain. So let's see a practical example. We can still use the one I have given here. Let's look at it. Say first, after identifying our parent chain, that's rule number 1. The rule number 2 is we should assign numbers to it. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Starting from the end, nearer to the first substituent. From the first substituent, this is my substituent here. Which side is nearer to this or this? If I want to count from here, this is 1, 2. If I want to count this side, it's 1, 2, 3, 4. So this substituent here is nearer to this side. So my numbering becomes 1, 2, 3, 4, 5. Remember, they say first, identify your parent chain, which is often the longest chain. 2, assign numbers to that parent chain starting from the end nearer to the first point where your substituent is. So this is my substituent, and that point nearer is this side. So I start from here 1, 2, 3, 4, 5. So that student, we would have this 5, 1, 2, 3, 4, 5, and you have your C here, and name it as 1, 2, 3, 4, 5. You're wrong. This is obviously completely different from this, so you cannot get the same answer. Yeah, will be wrong. So let's take another rule. So we have done that first one, and we have numbered them. Now the third one says, when two unbranched carbon chains have the same number of carbons, the chain with more substituent is the parent chain. As the example here, let's take this example. Okay. Let's take this example. Let me write it out. Now let's listen to the rule and know what we are doing. When two unbranched carbon chains have the same number of carbons, the chain with more substituent is the parent chain. So that example will tell us, when you count 5, for example, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All of them are 6, 6, 6. The question now becomes, which one do I take? They say the chain with the highest number of substituent, the one that has the highest number of substituent, become what? Our parent chain. So having counted these 6, let me now check the number of substituent. 1, 2, 3, 4, 5, 6. The substituent here is 1 and 2. So the first one gave me 2 what? Substituent. So I can clean this now. I have 2 substituent in the first one. If this is my parent chain, presumably, I'm counting. Now, if I come from 1, 2, 3, 4, 5. Okay, this is not even complete. 1, 2, 3, 4, 5, 6. Okay, this one is also 6. Now, the substituent is 1, 2, and 3. So, if I come from here downward, I have also 6 like the other one, and the number of substituent increases. This one is 3. So officially they say when you come from both sides and you have the same 6 in both, or 7 or whatever it is, you should now consider the parent chain with the highest number of what? Substituent. And this one definitely becomes my parent chain. So this becomes my 1, my 2, my 3, my 4, my 5, my 6. This becomes my parent chain. So we have not started naming them officially. I want us to finish the rules so that you understand when I make certain pronouncement because of what? Naming them. Because now if I go on, I want to name this. I say, this is 1, 2. This is a methyl. Am I right? And this one is an ethyl. 1, 2, 3, 4, 5, 6. There's another methyl here. Now, some of us may not understand that the ethyl will be pronounced first. Alphabetically, E comes before N. There is a rule that will tell us that. So, 1, 2, 3. We have 3 ethyl. Alright? Now, 2, 5 dimethyl. I have 2 methyls in 2 and in 5. So, it becomes 2, 5 dimethyl. Now, what is the parent chain? 6 hexane. So, that becomes the name of this organic compound. So, this is 3 ethyl, 2, 5 dimethyl hexane. Remember, when you are writing, let's call it 3 ethyl, 2, 5 dimethyl hexane. You must join them. You don't space hexane. Hexane. That's one common mistake we make. And I think you see that as we proceed further in the naming, in the rules you see. Now this is 3 ethyl, 2, 5 dimethyl hexane. When you space the methyl from the hexane, you are wrong. So that's how the rule goes. So let's continue. We are going to name many of them, tons of them. But before we get into the process of naming, we will see how we understand this whole thing. So that's the third rule. The fourth rule, when naming a substituent becomes a prefix joined to the parent name, and with its number or locant separated from its name by a hyphen. Now, these are the locant. Okay? These are the locant. These numbers which you have, 6, 5, 4, 3, whatever, are the locant. So you must take the locant into consideration. They are separated from the main name with a hyphen, and within two locant, a comma is used to separate them. So these rules we must have to follow. And also, if I do not see it, I just have to add to it. Let's take another rule. When the same type of substituent occurs more than once on a parent chain, let's take, for example, we have two methyl, one methyl and one methyl. When more than one occurs, what do we say? On a parent chain, their locants are separated by a comma, which is this, a comma between them. Okay, by a comma, an appropriate prefix, di or tri. How many of them? There are two, we call it di. If there are three, we call it tri. Tetra, etc. Added to the name of the substituent. Let's take another example. So first, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if this is what it is, but take note, your total locant must be lower when you are considering your parent chain. Listen, and listen attentively. Your total what? Locant. If I have this as 1, 2, 3, 4, 5. Another person have here 1, 2, 3, 4, 5. Let's consider where the substituents are. The substituents from this side are in 3 and 4. 3 plus 4 is 7. The substituents from this side are in 2 and 3. 2 plus 3 is 5. The lowest possible number or counting of locant is your parent chain. So it means the numbering must go from this way and not from that way. Are we together? The number must come from this way because here it gave us the lowest possible number of counting. But from this side we have 7, this side we have 5. So we abolish this other side. That side will be wrong. So many of us may make that mistake of starting from any position without minding where you should. At the end of the day, what you have will be what? Wrong. So here, like I was illustrating, if this is what it is, I have 1, 2, 3. In carbon 2, I have a methyl. Don't mind that I'm not putting my CH3 here. My CH3 here. We know that. I've explained that earlier on before I started. For those of you who are just coming in, you may not understand that. So now, if this is my methyl, this is my methyl, I have two methyl, I must have to show whether they are di or tri or tetra, as the case may be. So here become 1, 2. In carbon 2, I have a methyl. In carbon 3, I have a methyl. Am I right? So this become 2, 3. How many methyl? 2. 2 is called dimethyl. 1, 2, 3, 4, 5 as my parent chain, pentane. So that is how we move. You must take note of that. We're going to encounter a whole lot of questions which we are going to deal with. So when we get there, we'll cross. Let's continue numbering. Now, when the same substituent type is present more than once on the same carbon in the parent chain, its locant is repeated as many times as required, which is 2, 2, and so on and so forth. Let's take a practical example to that. We have this one, the locant is repeated as often as possible. So let's take this one. 1, 2, 3, 4. I have CH3 here, CH3 here. This is H3, remind me, H2, H3. This is in the condensed form. So now, if I want to count from here, first of all, I want to identify my parent chain, alright? I start from here, 1, 2, 3, 4. Now I have 4, but they say you should take the lowest, from the lowest possible side of the substituent, 1, 2. So this one is 2. So this is where I should definitely start. So I have 1, 2, 3, 4. So this becomes my parent chain from this order. Now in carbon 2, I have 2 methyl attached to it. Alright? Now they say you should repeat the number of locans as possible, as many times as possible, to reflect the number of times those substituents are attached to it. So now in carbon 2, I have 2 methyl. So I say 1, 2. So I have 2, because in carbon 2, I have 2, alright? 2 dimethyl. Dimethyl. How many? There are 2 methyl. Dimethyl. 1, 2, 3, 4. 4 is butane. So why am I having 2 is because in carbon 2 I have 2 methyls. So this is 2 dimethyl butane. So we are going to name a whole lot. Let's proceed further. Now we say again, when there are 2 or more different types of substituents, we have more than what? 2 substituents on the parent chain. They are arranged in alphabetical order. However, the presence of di, tri, tetra, etc. does not affect the alphabetical arrangement. Hence, let me give us a practical example that can illustrate that. Let's take this. Now, remember, I have explained earlier on in our first class that all of these, carbon is tetravalent, but you should also know that your carbon, your hydrogen are attached to them. So let us see. We say when there are more than one substituent that have different different from one another, we name them in alphabetical order. If this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, obviously I can now take from here because 1, 2, 3 is closer. Somebody tell this one to stop the moment. 1, 2, 3. So this side is closer. So I have it here as 1, 2, 3, 4, 5. So now if this is what I have, this is a methyl and this is an ethyl. So how do I name it? I have to name it alphabetically. 1, 2, N, ethyl, E. So obviously this comes before this, am I right? So this becomes 3 ethyl, 2 methyl, 1, 2, 3, 4, 5, pentane. Okay, methyl pentane. Remember, do not space it. It's very important. If you space it, it becomes strong. Let's move further if we have more rules. 8. When any of the following heteroatoms or functional group are substituents. Now we will have to tell you what are heteroatoms. They are named as prefixes to the parent names as indicated. Here, let me give you, we have the bromo, which is BRO, chloro, CL, fluoro, iodo, I. We have the nitro, NO2, the nitro group is a functional group. We have the methoxy, OCH3. We have the ethoxy, OC2H5, and so on and so forth. Now let us take a practical example that has to do with all of the heteroatoms therein, and we'll name them accordingly. So first, let us identify our parent chain. Then we name them accordingly. Now, if I want to start from here, this is bromine, this is chlorine, this is methoxy. So from here, 1, 2, 3, 4, 5 is my parent chain, or 1, 2, 3, 4, 5. So if I want to start from here, 1, 2, 3 bromo, 4 chloro. So 3 plus 4 officially is 7. But if I start from here, 1, 2, 3 bromo, 2 chloro, that's 5. It means I should start from here. This will give me the lowest possible count from these two. And this is methoxy. Alright, now let us see what comes first. We say alphabetically, am I right? So Alphabetically, we have B, A, B before C. So B will come first, bromo, then we have chloro, and we have methoxy. So let's begin. 1, 2, 3 bromo, 3 bromo, 2, 2 dichloro, because we have 2 chlorine and they are all in carbon 2. So that becomes 2, 2 dichloro, 2, 2 dichloro, 3 methoxy, 3 methoxy, 1, 2, 3, 4, 5, pentane. So that becomes the numbering. So you don't forget that alphabetical order is very important. Some of us may decide to start from the chloro first, forgetting that B comes before C. And when once that happens, you have made that mistake, and that will be very wrong. So let's take more questions. Okay, we get it. Now, from our parent chain, 1, 2, 3, 4 is closer than 1, 2, 3 here. So this is methyl, this is ethyl, alright? So if I call this 1, 2, 3, 4, this is my methyl. So I have E for 1, 2, 3, 4. 4 and 3 will give me what? 7. Am I right? Yeah, 1, 2, 3, 4. 4 and 5 will give me 8. So the counting must start from here because the possible number of the locant comes from this direction. Am I right? So that's number 1. We have identified that. So now this becomes 1, 2, 3, 4, 5, 6, 7. Now, if you look here, I have a methyl group. I have an ethyl group. All right. So ethyl will come first, which is this. But it is just not a normal ethyl. It has a substituent in it. So I will come over here. I want to start with 4. In carbon 4, I have an ethyl, which is 1, 2. This is the ethyl. So in 2, I have a chlorine. So this is 2-chloroethyl as a substituent in a substituent. So this guy is inside. So what do? I start from here. Since that ethyl must come first. So this is my 4 for that. Open bracket. I must have to put this inside. So here I have 2 ethyl, 2, sorry, that's chlorine. 2 chloroethyl. I'm done with this, am I right? Close my bracket. 2 chloroethyl in carbon 4. Remember, I'm supposed to say 4 ethyl. Now in 4, I have this. So that is why I have 4 outside. Put this hyphen to tell you what is inside 4. So this is 4, open bracket, 2 chloroethyl. 1, 2, 3. 3 methyl. 1, 2 to 7. Heptane. 3 methyl. Heptane. So that becomes the name. When you have a substituent inside a substituent, you must first of all show that this number 4 contains another substituent inside of it. You must show it before you proceed with the naming. Otherwise, that will be wrong. Let us move further and name more. This is another example that has something inside of it. All right. We have to first identify our parent chain. Now, if I start from here, 1, 2, 3, 4, 5, 6, 7. Okay? Okay, but this is a methyl. But this side is ethyl. Alphabetically, this one should be considered before this. But this one is an ethyl. So it is in between. Both sides give you 4, both sides give you 4. Now, why am I giving consideration to this other side? Only because this is Cl and this is N. Chlorine comes before methyl. Am I right? So by so doing, I start from here. So if this is my 1, 2, 3, 4, 5, 6, and 7. Now, this is a substituent, mind you. But in this substituent, it contains other stuff inside. Alright? So here I can call it 1, 2 if I like. Now let me start with my naming. I have Cl, and this is ethyl, E. So A, B, C, D, E. So I will start from here, am I right? So 1, 2, 2 chloro, 2 chloro, 4 supposed to be 4 ethyl, but there are other stuff. So I have 4 open bracket. In the ethyl, I have 1,1 dimethyl inside of this ethyl. So this becomes 1,1 dimethyl ethyl. That's what I will put inside the bracket before I move. So here I now have 1,1 dimethyl ethyl, close the bracket, 5 methyl heptane. Let me break it down. 1, 2. In 2 I have a chloro. So 2 chloro, 4, 1, 1. In carbon 1, this is my ethyl. 1, 2. Give me ethyl. 1, 2. But in carbon 1, I have 2 methyl. So I have 1, 1. In carbon 1, I have this 2 here. So it becomes 1, 1 dimethyl ethyl 5 methyl heptane. That is the name. Now let's take like 3 more examples in the naming process before we move further. I know we're going to deal with isomerism and so on, but it may not be today, but let's see what we can do. Alright, what is this one? No noise, please. Now, without wasting much time, we have to consider the parent chain first. Am I right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Either way, if we call this 4, we call this 64. If I take this as 4, this becomes my substituent. If I take this as 4, this becomes my substituent. So let's just deal with this. This one, 4 as our parent chain. So the parent chain is 4. Which member of the alkane family have 4? Butane. So first, our parent chain is 4, butane. Now, the substituent, they say we should consider the side closest to the end from the substituent. So if this is my substituent, if I take from here 1, 2, this is 2. It's closer than 1, 2, 3. Am I right? From here is 2, from here is 3. So I should come from here then. 1, 2, 3, 4. So according to that rule, this is the numbering. And each number is called a locant. So the lowest possible locant should be taken very seriously. 1, 2. Give me this. This side is 3. So 2 is considered. Now, in carbon 2, I have a substituent. What's the name of CH3? Methyl. Good. So the substituent name is what? Methyl. So now I would want to name it. We say 2-methyl butane. In carbon 2, I have a methyl attached to it out of the 4 carbon atoms. So this becomes 2-methyl butane. So by so doing, we have just name this one as 2-methyl butane. You don't have to memorize it. You just have to understand it. And when you understand, you flow. Let's take another one. So now we have to consider our longest chain, the parent chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All of them will give us 5. Then, if I take either this 5, this becomes my substituent. If I take it straightly, this is my substituent. If I come from this way, these two are my substituent. Let us deal with the straight chain, which is what? 5 in all. Now, let's consider where do we start from? Is this supposed to be the lower side or from here? Where do we call our 1? So let's check our locant. This is 2, 3, 4. Okay? 1, 2, 3, 4. But here in 2, we have 2, 2. Alright? Let's call that 2 plus 2, 4. For example, 4, 5, 6. So 4 plus 1, 6. But if you come from here, this is 2, 3. And you call this side 2 plus 2, 4. What do we get? 4, 5, 6. So either way is giving us the same thing, but let's take 3 as our shortest possible side. 1, 2, 3, 4, and 5. Now, in naming it, if you look here very well, you realize the substituent. What is the name of the substituent? This is the substituent. What is the name of this substituent? Methyl. Methyl. They are all what? Methyl. So now, if I start from here, this is 2. In carbon 2, I have 2 methyl. Am I right? So this becomes 2, 2, 4, because there's another methyl here. 2, 2, I've captured these 2 methyl. Another methyl is here in 4. Trimethyl means there are 3. 2, 2, 4, trimethyl pentane. Do we understand that?
Yes.
2, 2 what? 4 trimethyl pentane. By so doing, we have that all named out. So this is 2, 2, 4 trimethyl pentane. Let's take more, like 2 more, 3 or more than that. Depends on how the spirit leads. Okay. Quickly, we'll take 2 of these, then we'll go to interpret the condensed structures, which you may see anytime. If we now know how to interpret our condensed structure, then technically you should be able to answer any question that will come your way. So now let's go. Let's take this one. Okay. If this is what it is, let's see. B comes before C, am I right? So this is 1, we have B, 2, 3. So this is 1, in 2 here we have alphabetically this comes first. Then these 2 are even closer from here, which is 1, 2. Here will give us 1, 2, 3. So this side will give us the lowest possible word count. So if we want to start, B comes before C, L. 1 group, okay, let me name it, number 8, 1, 2, 3, 4. 1 bromo, 3 chloro. Remember alphabetically, you cannot call methyl before chloro. You call the alphabetically, this one comes before this, am I right? So 1 bromo, 3 chloro, 2, 2 dimethyl butane. So by that we are good. So now we have 1 bromo, 3 chloro, 2, 2 dimethyl butane. All right, let's take another one. Now, remember, first thing first, you identify the longest or the parent chain, which is the longest chain. So, if we look from here, 1, 2, 3, 4, 5, good. 1, 2, 3, 4, 5, 6. Okay, obviously this is the longest. Alright. So if that is the longest, let us check our locants and see which side we are going to start. If I start from here, let's call this 2 plus 3 plus 4. 4. Then we move further. We start from here 1, 2, 3 plus 4 plus 5. So this is 7, 8, 9. This is about 9, 10, 11, 12. So we must start from this side, not from this side. So if you start from here, obviously you will be out, because the lowest possible locant comes from this direction, not from this direction. You must do your calculation before you begin. So if that is the case, I will now number this 1, 2, 3, 4, 5, 6 as my longest chain. Now, F is fluoro. NO2, sorry, this is not NO3. NO2 is nitro. It is a heteroatom. And this is methyl, and this is methyl. So alphabetically, F comes before what? N, Abi? No, N, then N. So F comes first. This is second, Abi? And this is third. Is it also? M, N. So now, if this is the first guy I have to deal with, alphabetically, so let me name this guy. 1, 2. We say 2 fluoro methyl comes in. 2, 4 dimethyl, because there's a methyl here in 4, look at it. And there's a methyl here in 2. Am I right? Am I right?
Yes.
Do we understand?
Yes.
In carbon 2 there is a methyl. There is another methyl here in carbon 4. Look at how well we direct ourselves. 4, 5. So this is a substituent now. Because this isn't the parent chain, this is the parent chain, so this becomes a substituent. So now in 2 fluoro, 2, 4 dimethyl, methyl. Where is that guy? 3 nitro hexane. 6 nitro hexane. So that is how it goes. Very importantly, you must take note of that. So we should take a little of the condensed structures which can be given to you, and they will ask you to name it. So when it is given to you, you bring it out to make it larger, or you expand it, you simplify it before you proceed. In organic compounds, there are different forms. We can put them in the zigzag manner, in the condensed manner, and so on. So let's take one of them here. They say we should write the structural formula showing all bonds and the IUPAC names of the following. Now we have number 1. Now this is a condensed structure. They want you to simplify it, that you'll be able to name it and do whatever they ask you to do. Now what does this mean? This means that this carbon has 4 methyl group attached to it. Are we together? This carbon has 4 methyl group attached to it. Therefore, I have my carbon here, the 4 methyl group. 1 CH3, another one CH3, another one CH3, and another CH3. If you look very well, you realize that here I've not been writing it as CH3. This and this are not the same. Although it can be ignored that you are writing it in this form, it can be ignored, but it is preferable you write it this way, because the bond between carbon is interacting with another carbon, not with a hydrogen. So it's carbon-carbon bond. The process is called catenation, where carbon bond within themselves. So this is now what I have. The question here says that that you should write the structural formula, which is this now, all right? Showing all bonds, all of the bonds are visible, and the IUPAC name of this compound. Now, what is the IUPAC name? If I count from here, 1, 2, 3, 1, 2, 3, 1, 2, 3. Either way, they are all 3. So I just call it 1, 2, 3. So if this is true, now in carbon 2, I have 2 methyl attached to it. So this will become 2,2-dimethyl propane. 3 is what? Propane. Dimethyl propane. Alright, so we have 2,2-dimethyl propane. So our interest majorly is to be able to write out the structural formula and name it. Presuming that it wasn't given to us, it's like I'm giving you a structure to name. That is what we're doing. So let us take another structure and name it the way it should. So this can be given to you any moment, any time. But you have to use your senses to deal with it. Now, the first thing here we have is CH3. This is my C. H3. This is what I have. Now, here we have CH2. You know each carbon atom in between is having 2 hydrogen with it. So, but they say that this CH2, there are 3 of them. So I will now have CH2. This is 1. H2, this is 2. H2, this is 3. I move further. This carbon atom contains 1 hydrogen and 2 methyl groups. CH3 and CH3. This is what it is. So now we have the structure and we are asked to name. Obviously, 1, 2, 3, 4, 5, 6. Our parent name is what? Hexane. How many substituents do we have? Just 1. And it is in either 1, 2 or 1, 2, 3, 4, 5. 2 and 5, which one do we consider? 2, because it is closest to the beginning. So this is 2-methyl hexane. So can I write that? 2-methyl hexane. Let's take another. Now, this is 3-methyl group that should be attached to this carbon. So I have this carbon here. This one. The 3-methyl group CH3, CH3, CH3. That's settled. With this guy is over. Now this one here, I have my C. I have hydrogen and a methoxy group attached to it. OCH3. I extend. This carbon here, I have 3-methyl group. CH3, CH3, CH3. Now let us name this. From either side, they are the same. So let's just move. 1, 2, 3, 4, 5. Let's call it that. 1, 2, 3, 4, 5. Now, methyl and methoxy. Which one comes first? Methoxy. So 3-methoxy. This one. Sorry, yeah, I'm right. 3. 3-methoxy before methyl, alphabetically. Now, 2,2,4,4 tetramethyl pentane. Are we together? In carbon 2 we have 2 methyl. In carbon 4 we have 2 methyl. So we repeat the locant as many times as they appear. So now this becomes 3-methoxy 2,2,4,4 tetramethyl pentane. So that is that. 2,3-methoxy, 2,2,4,4 tetramethyl pentane. So that is the name of this compound. So you must take note and name it what? Religiously. I know there will be a section in your exam that has to do with name the following organic compounds. If you remember your basics here, I don't see how you're going to fail it anywhere in the world. So take note of that. As you move harder or higher, let's put it that way, in organic chemistry, you're bound to see things that will make your eye want to turn, but you know how to deal with it. Okay. Now, they say we should write the structural formula of the following. 2,3-dimethylbutane. I think that is straight up. 2,3-dimethylbutane. You just, your butane is 4. 1, 2, 3, 4. They say 2,3-dimethylbutane. That's that. Those are walkover questions. Now, the IUPAC nomenclature of the compound above. Okay, this is very important. Most of us will make mistake in this. Let's take this as our last one. And I strongly believe even if I should allow you to name it, 99.9% of you will not get it. Well, let's see. They say, what do they say we should do with that guy? We should give the IUPAC nomenclature of the compound. It's a jam question. They have options here, various options. 5-ethyl-octane, 5-propylheptane, 3-propylheptane, 4-ethyl-octane. We'll see which one is correct. Now, let us break it down. This is my CH3. I have 2 CH in 3 places. 1, 2, 3. This one is gone. And here I have C, which contains hydrogen, and C3. 1, 2, 3. H7. 1, 2, 3, 4, 5, 6, 7. Move further. C2. This is my C2. H5. 1, 2, 3, 4, and 5. Now, if you see it this way, this is a substituent, if you want to capture it that, or base is a substituent. But now, according to the rules, they say we should name the longest parent, the longest chain, the longest possible chain as the parent chain. So if I want to name the longest, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this becomes my longest. A lot of the students may likely go this way because it is horizontal. And by that, you will not get it right. So if this is true, 1, 2, 3, 4, 5, 6, 7, 8. That noise is terrible. So here becomes 4-ethyl-octane as the name. So 4-ethyl, this is CH2, this is your substituent. All of this is the parent chain this way. This is attached to this as your substituent, which is C2H5. So that is your substituent. So the answer to that question in JAM, they say 5-ethyl-octane wrong, 5-propylheptane wrong, 3-propylheptane wrong, 4-ethyl-octane. That is the answer. Thank you and have a nice day.